Right now, a massive star in a galaxy 22 million light-years away is vanishing. No explosion, no warning, just gone, and the astronomers at NASA and Hubble tracking it in real time have absolutely no idea what took it. But here's what nobody is telling you. This wasn't the first disappearance, and whatever is erasing these stars may already be watching the ones in our own backyard. That star had a name, N6946BH1. It lived inside NGC 6946, a spiral galaxy astronomers nicknamed the Fireworks Galaxy, because it produces more confirmed supernovas than almost any galaxy we can observe. 8 in the last 100 years. This place is a graveyard, and when a massive blue supergiant inside it started brightening in 2009, swelling, pulsing, radiating energy across 22 million light-years, researchers pointed the Hubble Space Telescope directly at it. A star 25 times the mass of our Sun was supposed to die in the most violent way the universe allows, a core-collapse supernova, an explosion bright enough to outshine every other star in its galaxy for weeks. They trained their instruments on it. They waited. They expected a detonation. Instead, the star dimmed. Then it faded. Then it was gone. No blast, no shockwave, no superheated debris expanding at 10,000 kilometers per second. Just absence. A star 25 times more massive than our Sun quietly ceased to exist between one observation and the next. Researchers returned to the coordinates in 2015. Hubble found nothing. Spitzer, which sees in infrared pure heat, found nothing. Chandra's X-ray array, sensitive enough to detect a single high-energy photon from across a galaxy, found nothing. No compact remnant, no ring of ejected gas, not a whisper of light at any wavelength. A massive star that was visibly alive in 2009 had by 2015 simply stopped existing. That is not how stars are supposed to die. The leading theory is something called a failed supernova, the idea that some massive stars collapse so completely so fast that the energy of the implosion never escapes. The core implodes. A black hole forms in milliseconds, and the star doesn't explode. It falls inward, swallowed by its own gravity in a fraction of a second, quietly, with no visible trace. But that explanation has a problem. A star of that mass carries staggering angular momentum, intense magnetic fields, and a neutrino flux powerful enough to shred its outer layers on its own. Multiple independent mechanisms should produce a detectable signal. Every instrument we have found nothing. The research team published their results, then admitted carefully that they could not actually confirm what happened. But here's the strange part. It shouldn't be possible at this rate, because N6946BH1 wasn't alone. Astronomers have been counting stellar deaths for decades, building precise models that predict how many massive stars should explode as supernovas each year. The math was tested and cross-referenced across institutions. Then the surveys came back wrong. Stars above a certain mass threshold are disappearing at roughly twice the rate they should be dying in visible supernovas. The most massive objects in the universe, the ones with the most energy and the least excuse to go quietly, are vanishing without detonating. Scientists have a name for the statistical gap this creates. They call it the red supergiant problem, and after years of serious investigation, there is no accepted solution. Some researchers think the stellar evolution models themselves are flawed. Some argue these stars shed so much mass in their final years that they drop below the energy threshold for a visible explosion. One team proposed an unmapped interaction between extreme gravity and magnetar-class magnetic fields, a mechanism current physics cannot describe. Another possibility, raised in peer-reviewed journals, is that the most massive stars collapse through a phase transition that quantum chromodynamics simply cannot yet model. None of these has been confirmed. Every explanation has a hole, and the stars keep disappearing. What this means is something researchers tend to bury in methods sections of papers most people never read. It means one of the most energetic processes in the known universe, the death of the most massive stars, is happening in a way we cannot predict, cannot detect, and cannot explain. We have instruments sensitive enough to hear gravitational waves from colliding neutron stars on the far side of the cosmos. We can resolve individual stars in galaxies tens of millions of light years away. And something is silently erasing massive stars at a rate that doesn't match any model we have. The Fireworks galaxy is 22 million light years away. That distance feels safe, but the same class of dying massive stars exists throughout the Milky Way. Betelgeuse, 700 light-years out, is already swelling into its final phase. WR-124, VY Canis Majoris, objects burning for millions of years overdue. If the same mechanism that took N6946 BH1 is already active closer to home, we would not see a flash. We would not detect a shockwave. We would look up one night and a star that was there yesterday would simply be gone. So the real question isn't what killed N6946 BH1. The question is how many others have already vanished that we haven't noticed yet. Drop your answer below.